this is going to be the first two examples of the work formulas. We're going to just go one at a time here, start with the easiest one, and that is find the work done lifting a 135-pound barbell 5 feet. Now what I have envisioned for this one is just like a bench press where you're going directly up, but I didn't think about it too much as I was writing this problem because if you're going to lift that 5 feet, you have to be a Stretch Armstrong, but we'll just assume that these are okay. And so the work done lifting that, the work is going to go in the exact same direction as the force. And so work in this case is going to be magnitude of F times the magnitude of the direction vector, in this case AB. So that just means that, well, these are the two magnitudes, and so we do 135 times 5, which is going to give us 675 foot-pounds. So that's the simplest one. That's number one. Number two is going to be for this second version of the formula, and that is work equals a force dot AB. And so in order to do this one, we have to have two vectors, but let's first of all look at the problem. So the problem says, find the work done by a force F of 24 pounds acting in the direction of 4, 5, moving an object from 5 feet from 0, 0 to 5, 0. Here's kind of what this situation looks like. This situation has this, whatever this thing is right here, we're going to move it from 0, 0 to 5, 0. So what I would start with is the direction vector. And the direction vector, the AB, is just going to be, in this case, if it goes from 0 to 5 for the x's, that's 5. And from 0 to 0 and the y's, that's 0. So this is going to be our AB. That's our direction vector in this case. Then we need to find the force vector. Now the force vector is, it says it's going to be going in the direction of 4, 5. And so thinking back to our formula for vector with a direction and magnitude, it's this whole thing. We know that the magnitude, they're telling us that it's 24 pounds. So that goes out here to start with, it's 24. The vector, as far as unit vector in this direction, we have 4, 5, and we're going to do cosine and sine. Now with this one, we need to, for one thing, we need to know what the cosine and sine is of this. Like, imagine that you're pulling on the wagon with the handle up this direction with 4 and 5. It's a good idea to know what your hypotenuse is as well. So if you do the formula with the square root of 4 squared plus 5 squared, this ends up being square root of 41 for that hypotenuse. So now if we're talking cosine of this setup, then it is 4 over square root of 41. For the x part, the sine is going to be 5 over square root of 41. And we don't really need to know the angle, we just need to know how that's set up. And so this is going to be our force vector, which is approximately, we're just going to approximate this to a couple decimal places, but it's really, really close to 18.74 as our force vector for this one. So we have our force vector, we've got our movement vector. If we can get both of those things, then we apply the work formula and we just do the dot product. So force dot AB, we do x times x, so that's 15 times 5 plus y times y, 18.74 times 0, which is kind of nice. That just ends up being 0, and so then 15 times 5 is just 75 for our solution, and that's going to again be in foot-pounds.